Okay, so let's take a look at some of the details of this assignment. If you haven't already, I really highly recommend that you take a look at Chapter 3 of the free lab manual. It goes into some nice explanations of topographic maps and into more detail of some of the features that we've discussed already in this video. It's available in the content area in D2L, so go have a look before you get started. So in this part of the assignment, your job is to label the elevation of all of the topo lines in this map given a contour interval of 40 meters. So I'll help you get started, give you a few little hints here as well. So first of all, we're told that this is the shoreline, so that's the shore. Think of that as sea level, so that has an elevation of 0 meters. So there's one useful hint. Here's another hint that these two index contours have the same elevation. It's totally legal for two lines of the same elevation to be on one map. Another hint is related to this feature here. This blue line represents a stream. And so we can use this to figure out which way is uphill and which way is downhill in this section of the map. So here's the hint. When streams flow, when two streams meet, they meet and join and flow in the downhill direction together. They join together, but they don't split. When streams are flowing downhill, they join together, but they don't split. One last hint is related to this feature here. I mentioned previously in the video that a series of circles, contour lines represented as circles, represent cone features. But you can have cone-shaped mountains and cone-shaped depressions. So how do we know which is which? And that's what the little tick marks tell us. These little brown short tick marks, which I'll draw here, tell us something about the downhill direction. If you have a bunch of circles like this, the tick marks point in the downhill direction. And so these two circles, these two topographic line circles, represent a depression. In other words, the center is lower elevation than the surroundings. All right, there's my hints. Good luck. So in this part of the assignment, your job is to take this map of elevations and draw the corresponding topographic lines. And we know a couple of things. One is that we're given a contour interval of 100 meters. And so we want to draw lines representing elevations of 100 meters, 200 meters, 300, etc., all the way up to 700 meters. The second important thing to remember is that contour lines, topo lines, represent lines of constant elevation, and so they connect points of the same elevation. Even if those points aren't labeled, we can figure out where they are. So I'll do the first one for you. I'll do the 100-meter elevation contour line. And so here's a point of 100 meters, and so I'm going to start my line there. So I'm drawing the 100-meter line. And so I don't see any points in my vicinity labeled at 100, but I can figure out where the line has to go. I see a point above 100 and a point below. 132 is above and 70 is below. And 100 must be in between those two somewhere. So I'll take my line there. So now again, I'm going to look around for points that are larger and smaller than 100. The 100-meter line has to go in between those points. So I see 132 and 160. 100 isn't in between those, but I see 160 and 12. And 100 is in between those, and so the line must go roughly there. Again, look around for points that are larger than 100 and smaller than 100. I see 160, I see 95, and so 100 is between those two and closer to 95, so I'll take it about right there. And here I see 210 and 107. Well, both of those are larger than 100, so the 100 line doesn't go there, but I see 95 and 107, and 100 is in between those two, and so the line must go there, and I'll just finish it and take it off the map somewhere there. So that's the 100-meter contour line. Next, you need to draw the 200-meter contour line, and I'll get you started there. I don't see any points on my map really anywhere that are labeled with 200 meters, so where should I start? Well, I do see this 100-meter point and this 290-meter point. And so 200 is in between those two, roughly in the middle. So let's say that point is 200 meters. So here's my 200-meter contour line. And you need to follow this procedure to finish the line. Look for points that are larger than 200 and smaller than 200 and head in between them, and then keep going. There are a number of questions in the assignment regarding interpreting this topographic map. A number of things you need to look at and figure out, and some calculations to do. One is the regional relief. Regional relief is just the highest elevation on the map minus the lowest. So you need to figure out the elevation, all of the contour lines, find the highest one, find the lowest one, and then do the subtraction. You need to also take a look at the map and figure out which parts are steeper. In other words, you're going to be looking at from A to B versus B to C. Which parts are steeper and how do you know? Another calculation you'll have to do is the gradient between points A and B and between B and C. The gradient is a way to measure, a way to quantify how steep a portion of a landscape is. And the gradient is calculated between 2 points as the difference in elevation. So you need to figure out the elevation of the 2 points and then subtract them to find the difference, and you divide by the distance between those 2 points, and you can figure out the distance using the scale in the lower right hand corner. And lastly, you're asked to think about this map in terms of some real landscape features that glaciers produce. Based on the shape of the main feature in this map, you can figure out which way, if it was produced by a glacier, you can figure out which way the glacier was flowing at the time when it made it. So here in this part of the assignment, you're going to be creating a topographic profile. You're going to be taking a look at the shape of this landscape along this red line, A to A prime, and figure out which parts are uphill, which parts are downhill, etc. And so what we need to do first is figure out the elevation of all of the lines that the red line crosses, the elevation of the contour lines that the red line crosses. Some of them are labeled, like the 800 line here and the 900 line here, etc., but most of them are not. However, using the contour interval, which we will figure out, we can figure out the elevation of all of these lines. So that's the first job. So let's do that. So first of all, we know that the elevation of this line is 700, the elevation of this line is 800. So we need to figure out the contour interval in order to figure out the elevation of all the other lines. So to go between the 700 and the 800, there's 1, 2, 3, 4, 5 lines. And so the contour interval, we take the difference in the two elevations divided by 5. The contour interval must be 20 feet. So if this line is 700, this one must be 720, this one must be 740, etc. You can use that to label the elevation of all of the rest of the lines in the map. So once you know the elevation of all of the lines, you can then create the topographic profile. In the previous example, I explained this by using a small piece of paper that you lay along your path along A to A prime. You put little tick marks on it. Then you take that piece of paper down to your graph paper and use that to make the dots in the profile. In this case, we've made this easier. We've set it up so that you can skip the middle step of the small piece of paper. We put the graph paper right below the map in just the right spot, and so you don't need the small piece of paper and the tick marks. What you do is you look at all of the places where the red line crosses contour lines, like there, 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 etc. All of them, all the way across the map. And you figure out the elevation of this point here, the elevation of this point. That dot is on the 740 line, so the elevation is 740. These two dots here and here are 720. This dot also lives on the 740 line, etc. And so then I go straight down from each dot. Once I know their elevation, I go straight down and I put a point at 740 on the graph. These two dots here, I'm going to go straight down and put 2 points at 720 and 720, etc. You go straight down from the point once you know its elevation and put its dot on the graph paper. Once you've done that for all the points all the way across the map, you connect those dots and then you have a profile. You know exactly the shape of the landscape along that path. Okay, finally, the last thing that we need to do for this assignment is calculate this thing called the vertical exaggeration. In the last step, you produced a topographic profile, the shape of the landscape along this red line A to A prime. But the way we did it, it's exaggerated vertically, meaning it shows things to be steeper, way steeper than they actually are. So it'd be nice to have some sense of just how much that steepness has been exaggerated. And so this vertical exaggeration calculation will tell us that. And so to do the vertical exaggeration, we need to know the horizontal scale and the vertical scale. So let's figure those things out. So the horizontal scale is given to us, 1 to 24,000. So what that means is that 1 inch on the map is the same as 24,000 inches on the real world, on the real landscape. And since 24,000 inches is the same as 2,000 feet, there's our horizontal scale. 1 inch on the map corresponds to 2,000 feet on the real landscape. So now we need to figure out the vertical scale. This one we'll have to measure. So this, we go to our graph paper, and on the vertical axis of the graph paper there's a bunch of elevations here labeled 700, 800, 900, 1,000. So what we need to do is actually measure an inch on our graph paper and figure out how many feet that corresponds to. And so if I measure on this graph paper starting at 700, let's say an inch is that much. I didn't actually measure this. You'll do a better job on yours, but let's say that much is an inch. So how many feet does that correspond to? Well, this line goes from, it's roughly 860 feet, and I started at 700 feet, so that's 160 feet. So we just measured the vertical scale. 1 inch is the same as 160 feet. And so here's my vertical scale. Now to calculate the vertical exaggeration, I take the horizontal scale, which is that 2,000 number, divide by the vertical scale, which is that 160 number, and we get some resulting value. So yours will be slightly different than mine depending on how your printer scales the images when it prints it, but roughly speaking, you should get something about 15. In other words, the vertical axis of this profile is exaggerated 15 times compared to the horizontal. If you get something wildly different from 15, just go back and check your measurements and calculations. Okay, that's it. That is the end of the assignment intro video. When you're done, submit it to the Assignment01 Dropbox as one file, please, either as a Word document or as a PDF. One option for doing this assignment is you print the thing out, you do it by hand, you take pictures of the whole thing or the relevant parts, assemble those into a document and submit that, or you can just scan the whole thing and submit that as a PDF. All right, good luck.